Okay, welcome everyone. This is a video to go over the Get Ready assignment for Chapter 6. And we're going to be reviewing fractions and polynomials today to get ready for this chapter. This goes all the way back to probably grade 8. We are going to be adding and subtracting, multiplying, dividing fractions, so we need to remember the rules for those. So let's just start with the adding and subtracting. If you feel already like you know this, please skip ahead to the part of the video where you need to do it with me. Otherwise, you can also do this assignment on your own. You don't need to watch this video and then just check your answers with the answer key. Okay, here we go. So when we're adding and subtracting fractions, the key thing to remember is that you need to have a common denominator. And then you just add or subtract the numerators once you have that common denominator. So this one's already done for you. The common denominator was 24. 6 and 8, that's the lowest common multiple, is 24 between the two of those numbers. And then we use that. Okay, so let's do the next one here. Let's look at the denominators. They're not the same, so we need to get a common denominator. And in this case, the common denominator would be 12 because I can make 3 into a 12 by multiplying by 4. So you want to pick the lowest number possible. So this would turn into 8 over 12 plus 7 over 12. Now that we have a common denominator, I just need to add the numerators together. So that would be 15 over 12. And now your final answer should be reduced. So this one can divide by 5. No, sorry, you can divide by 3. So you get 5 over 4. You can also write that as a mixed number. We're not going to worry too much about that in this chapter, so 5 over 4 is totally fine. Okay, next one. And again, you can pause here at any time and work on these on your own. So the lowest common multiple between 5 and 3 would be 15. So I'm going to multiply the fraction on the right side by 5 and 5. And the reason you can do this is because by multiplying both the top and the bottom by the same number, you're actually essentially multiplying the fraction by 1. You're not changing the fractions when you do this. So this would be 12 over 15 minus 10 over 15. Now that our denominators are the same, we can simply just subtract the numerators. So you'd get 2 over 15. And this one does not need to be reduced. So that's our final answer. And finally here, the lowest common multiples of 21 and 14, they're both divisible by 7. So the lowest common multiple here is going to be actually 42. If I multiply 14 by 3, I'll get 42. And if I multiply 21 by 3, by 2, I'll get 42. So that will be 28 over 42 plus 9 over 42. Adding those numerators together, we get 37 over 42. Okay, there we go. All right, so that's adding and subtracting. You need a common denominator. That's the key thing to remember. We're going to be using that throughout the chapter. Okay, multiplying fractions. Now, what we need to recall here is that the rule for multiplying fractions is very simple. You can simply just multiply the numerators and multiply the denominators. You don't need to have a common denominator. But to do it, I guess, efficiently, you need to remember that we want to cancel any common factors in the numerator and denominator first before you multiply. That reduces the amount of simplifying you need to do at the end, especially if the numbers are really big, like we'll see in these examples. You want to simplify first. We're going to be seeing that throughout the chapter. And if you don't do that, you're not going to be successful. So let's have a look at this first one that's already done for us and how I actually simplified it. Again, feel free to stop anytime and try these on your own. Okay, so we're going to focus on the numerators and the denominators. Any common factor, which means any number that divides into something in the numerator and something in the denominator, we can cancel out. So let's have a look at these two first. The 7 and the 21, both of these can be divided by 7. So you can do that. If one's in the top, one's in the bottom, you're free to cancel. So 21 divided by 7 is 3, and 7 divided by 7 is 1. Let's have a look at the 6 and the 16. Both of these are even, so they can be divided by 2. This would become 8, and this would become 3 when I divide by 2. Okay, so now I have some new fractions to multiply. 3 over 1 times 3 over 8. The numbers are a lot smaller. I'm not going to have to simplify in the end. I get 9 over 8. Okay, so again, pause this anytime and try yourself, but I'll go ahead and do these again. Let's have a look at the 21 and the 14 first. These can both be divided by 7, just like in the previous example. So 21 divided by 7 is 3, and 14 divided by 7 is 2. Now we're going to have a look at the 8 and the 24. Those can be both divided by 8. So sometimes you'll find a common factor and sometimes you won't. But if you do, you definitely need to divide by it and cancel first. So now this question becomes a lot easier. It's just 1/3 times 2/3, which would be 1 times 2 is 2, 3 times 3 is 9. Okay, let's do the next one. So anything in the top can be canceled with anything in the denominator. 33, oops, I'm using the wrong color here. 33 and 22, those are both double numbers, so that means they can be divided by 11. So that would be 3 and 2. 20 and 70, they both end in 0, so they can be divided by 10. So now this becomes a lot simpler. It's simply 2/3 times 2 over 7. That would be 4 over 21. And finally, we have 2 numbers in the top, 2 numbers in the denominator. Okay, 25 and 85. These are both ending in 5. They can be divided by 5. So 25 divided by 5 is 5. 85 divided by 5 is 17. And these 2 numbers can be divided by 6. So I get 1 and 3. Okay, so this would be then 5 over 3 times 1 over 17. 3 times 17 is 51, and 5 times 1 is 5. Okay, great. And just as a quick note, this is a lot easier here. 3 times 17 is not the easiest multiplication to do in your head, but it's way better than 18 times 85 would have been, right? So the purpose of multiplying before is that we're making the numbers a lot smaller, a lot easier to multiply, and we won't have to simplify at the end. Okay. When you're dividing, you want to do the same thing. You want to cancel before you multiply. The rule for dividing fractions, remember, dividing is the opposite of multiplying. So you can actually just multiply by what we call the reciprocal number. So we want to, sometimes people remember it as keep, change, flip. So we keep the first number as is. So 14 over 15 would stay the same. You change the sign to multiplying, and you flip the second number. So it becomes 3 over 2. And then you simply proceed like before with multiplying. So if you want to pause the video here and try some on your own, you can, or you can do them with me. So we would keep 7 over 25, change the sign to multiplying, flip that second number, so use the reciprocal. And now we want to make sure we cancel anything just like before. So anything in the numerator can be canceled with anything in the denominator. So 7 and 14, those can be divided by 7, so 2 and 1. 45 and 25, those can be divided by 5, so I get 5 and 9. And this would be 9 over 10. Okay, so you don't want to cancel in the division format. You want to cancel once you're in the multiplication format. So keep, change, flip first, then cancel, and then evaluate. Okay, so this one, keep, change, flip, and then I can cancel out. So 10 and 2, I can divide those by 2. 5 and 11, those can't be simplified, so I'm ready to go now. So this would simply be 25 over 11. There we go. Okay, and last one, if you have a whole number, this is just a reminder that that is the same as 4 over 1. Any whole number has a 1 in the denominator. We're just not used to writing it. So we still use the keep, change, flip. The rules don't change. And then we do our cancellations, 16 and 4, those can be divided by 4. So simply have 4 over 21. Okay, great. We're going to be using all of those, multiplying, dividing, adding, subtracting throughout the chapter. And even though we're going to be doing it with polynomials, the rules actually stay the exact same. So no matter whether you're adding a really complicated looking fraction or one with simple numbers, you don't change the rules at all. So all of those rules we just learned or went over there, we have to remember them for the upcoming chapter. Okay, we're also going to be working a lot with polynomials, which we learned earlier in this course. So let's just recall quickly how to factor. Feel free again to stop the video here and try these on your own, see how much you can remember. Oh, sorry, that's not what I want here. Okay, so when the leading coefficient is 1, we can simply use the following trick. We're thinking of two numbers that have a product of -20 and the sum of that middle term, which is -1. The two numbers are -5 and 4. So then we would simply just write our factors like this: x minus 5, x plus 4. -5 times 4 is -20, and when you add them together, they're -1. Okay, this is a difference of squares. So the two numbers I'm looking for are going to be the same but opposite signs. So this is going to be x minus 4, x plus 4. Okay. In this next one, we have to remember our key question we always ask ourselves before factoring the trinomial, which is there a common term we can factor out? So in this case, there is. We can take out a 2 from every term. And then I do the same as before, asking myself, what has a product of 8 and adds to 6? Okay, 2 and 4. So x plus 4, x plus 2, and we still have this 2, this common factor sitting on the outside there in our final answer. Okay, next question. Our leading coefficient is not 1, and there is no common factor to take out because 3 is not a factor in every term. So what we're going to do is you can do this by guess and check, or you can do it by decomposition. I'll do it by decomposition just to review it. So we take the product between the first and the last. So that would be 3 times 5 is 15. And the sum is still that middle term, so 16. So our numbers there would be 15 and 1. So we split up that middle term into 15x and 1x. And then we factor the first 2 and the last 2. So we can take out 3x in the first 2. We're left with x plus 5. And there's no common factor in the last 2, so we just simply take out a 1. We have x plus 5. And notice now we have x plus 5 in both. So we factor that out. We have x plus 5. And from the first term, we'd have 3x. And from the second term, we'd have a 1. That's the final answer there. So feel free to do these questions by guess and check or by decomposition. This next one here, my product would be -28. My sum would be 3. So my numbers I'm looking for are 7 and -4. Split up that middle term, plus 7x minus 4x minus 14. Okay, factor, you can take out an x here, 2x plus 7, and can take out -2. I have 2x plus 7, and then finally, 2x plus 7 is common in both, and I have x minus 2. Okay, and last one, product would be 12. Sum would be -8, so -6 and -2. Wait. Product 12, oh, so sum -8. Yeah, -6 and -2. I was ahead of myself there. 4x squared minus 6x minus 2x. Yeah, that works. Plus 3. Factor the first 2 terms. I can take out 2x. I have 2x minus 3. And I can take out a -1. So I have 2x minus 3. And 2x minus 3 is common in both. And then I have 2x minus 1. Okay, perfect. Okay, expanding and simplifying. So in addition to factoring, we're also going to have to be comfortable with lots of different operations with polynomials. So expanding and simplifying, you're going to need to do in this chapter. So I'm just going to review foiling really quick. Again, if you want to pause the video here and just try these on your own and check the answer key, totally fine to do so. We want to FOIL first and then subtract. So we want to use BEDMAS all the time when we're evaluating any expressions or simplifying them. So we'd have x squared. The two middle terms would be 3x and 4x. If I were you, I'd get confident just adding those middle terms in one step, and then plus 12. So that's our first expansion done. And then I'm going to have minus, and then I'm going to have my second expansion here. So x squared plus 5x plus 1x plus 5. X squared, the middle term would be 5x plus 1x, which is 6x, and then plus 5. Now I want to subtract these entire polynomials from each other, not just the first term of that second polynomial. So let's look at the like terms. I have x squared minus x squared. That's going to go away and cancel out. Then I'll use different colors here, 7x minus 6x. So that will be 1x, or just x is fine. And then finally, I'll have 12 minus 5. So that's 7. So I simply have x plus 7 as my final answer. So x plus 7 is equivalent to this big expression that we started with. So the purpose of simplifying is it makes the expression a lot simpler, obviously. Okay, let's do the next one. Again, pause here if you want to try it on your own. So we're going to FOIL that whole thing out. And x plus 1 squared is the same as x plus 1 times x plus 1. So I'm just going to rewrite it like that. And I'm going to FOIL that one out. Okay, so I'll have one expression minus another expression. So I'll have 2x squared, and then the middle terms will be 6x minus 1x. So that'll be 5x. Then I'll have minus 3. And then I'll have x squared. Middle two terms will be 2x, and then plus 1. So again, we want to look at like terms. 2x squared minus x squared. So that would be 1x squared. Then we have 5x minus 2x, so that would be 3x. And finally, negative 3 minus 1. So that would be negative 4. Okay. So I like to put the brackets around after I've done my expansion there, especially if there's more arithmetic to do, just because that gives you the sense of like, okay, you're subtracting this entire polynomial, not just the first term in it. It helps me remember that. So I would recommend that you do the same thing as well. Okay, great. One final section left to do. This is just a little review of how to plug in a value when you have an expression. So we're going to be plugging in x equals 2, x equals 0, and x equals 1 into these different expressions. And we're also going to look at some different cases where maybe the answer is undefined. So let's go ahead and just go to this first one here. Again, pause the video if you want to just try this on your own. So wherever there's an x, we're going to plug in these values here. We're going to have 3 separate answers for 3 different values. So for the first one, I'd have 2 plus 1 divided by 2 plus 2. So 2 plus 1 is 3, and that would be 4. This would be 3 over 4, or you could write 0.75. Both are fine. So when x equals 0, I'll have 0 plus 1 over 0 plus 2. 0 plus 1 is 1, 0 plus 2 is 2. Okay, there we go. And the last one, 1 plus 1, 1 plus 2. So that would be 2 over 3. Okay, so none of those were undefined there. Let's check the next line. Let's go here. So 3, and we're going to plug in the value wherever the x is. So if x equals 2, I'll have 2 minus 2. So this would be 3 divided by 0. Now, you can have 0 in the numerator, that's fine, but you cannot divide by 0. If you take your calculator and try and do it, it'll give you an error. So we say that this is undefined. There is no value for 3 over 0. Okay, let's plug in 0 here. 0 minus 2. 0 minus 2 is negative 2. You can also write like this. Negative 3 over 2. Both of those are the same number. Okay, and then for 1, this one will be defined as well. This will be 3 divided by -1, which is just -3. Okay, great. So notice the one that was undefined was the one where the denominator was 0. So if the denominator can be 0, then that's where it's going to be undefined. Okay, let's go to the next ones. We're plugging in 2 here to these 2 spots. And in the denominator, I'm multiplying this time. So 2 minus 1 is 1. 2 plus 2 is 4. So this would be 6 divided by 4, which can be reduced to 3 over 2. Next one, plugging in 0. So 0 minus 1, which is -1, and 0 plus 2, which is 2. 6 divided by -2 is -3. The last one, though, you'll see is going to be undefined because when I plug in 1, this first term will be 0, and then I'll have 3. 0 times anything is still 0. So this is 6 over 0, which is undefined. You cannot divide by 0. So if you have a factor in the denominator that's going to be 0, your whole expression will be undefined. Okay, and the next one. It looks a little bit more complicated. Some people find it a little bit easier if you want to factor the denominator. You can also plug it in that way, but you should get the same answers if you leave it as x squared minus 4. So I'm just going to leave it. And this time we're plugging in 2 x values. So I'll have for the first one 2 over 2 squared minus 4. 2 squared minus 4 is 0. So this is going to be undefined here. Okay, next one at 0, we'll have 0 over 0 squared minus 4. That's 0 divided by -4. That one's not undefined. So you are allowed to have 0 divided by a number. You just can't divide by 0. So this one is just equal to 0. And lastly, we have 1 over 1 squared minus 4. And this is 1 over -3 or -1 over 3. Either way you want to write it. Okay, there you go. So what you should notice there is anytime the denominator is 0, it's going to be undefined. So any x value that makes the denominator 0 makes the whole expression undefined. Okay, and we will pause the video there. That's the end of the Get Ready assignment.